Okay, here's part 2 of the video because I accidentally clicked the stop button. Okay, so in the second one, they give you slope. In the first one, you had to find it, and this one, they give it to you. So this one's going to be pretty easy. So you have the m, the x1 is your first x, your y1 is your y. Those don't change. So we're going to plug this in. We're going to get y minus y1, which is 2, equals m, which is 2, times x minus x1, which is 4. Okay, we don't have to worry about any of the little signs here because we only have one negative sign. So what we're going to do with this 2 is we're going to distribute it. It's going to go to the x, it's going to go to the 4. We're going to get y minus 2 equals 2x minus 8. Finally, we have to get rid of the 2 next to the y. So we have to add 2 to both sides. We get y equals 2x minus 6. And now it's in y equals mx plus b form. Okay, I want you guys to try these next 4. And then go on to the next part of the video. Okay, now trying to find the equation for a graph. So there's 2 ways. On the test a few weeks back, I made you guys find 2 points and find the slope and do what we just did in the previous couple of problems. I'm going to show you the shortcut. Both ways work, so if you want to do the other way, you can do that, but this way I'm going to show you the shortcut. So remember, when you have y equals mx plus b, you have 2 parts. You have the slope and you have the y-intercept. Remember, the slope is your rise of your run, how much you have to go up and how much you have to go over to get from one point to the other. And your y-intercept is where the line crosses the y-axis. This is one that goes up and down. Okay, so y-intercept is pretty easy to find. What number is pointed right there? So right there we've got a negative 4. So our y-intercept is negative 4. I'm just going to put yi negative 4. Now let's find our slope. To find the slope is a little bit harder because we have to find 2 points that actually line up. So here's one point. And I believe this is another point right here. So we're going to figure out how much we rise over how much we run. So we're going to count. We're going to go up 1, 2, 3, 4. We're going to go over 1, 2. So we went up 4, positive 4, over 2. So our slope, which is going to be our m, is going to be 4 over 2. Or when we reduce that, that's actually just 2. So we know our m is 2, we know our y-intercept is negative 4. So all we gotta do is plug them in. The y doesn't change just like in the previous problems. The m is a 2, the x doesn't change, and then the y-intercept is negative 4. That's the quick and easy. Otherwise, you would have to find the slope. See that this point is 0, negative 4, this point is 2, 0, and then you'd have to do this whole thing that we did in the previous problem to figure out your slope. I mean, not your slope, your equation. So, when you guys have this, you'll have 2 little graphs here. Right now I don't have it because I need to draw them on and give them to you tomorrow. Now, line of best fit. You guys will have this all labeled here, but for right now I don't have it labeled, so I'm going to label it for you. So I'm going to put 1, 3, 5, 7, 9, 11, so on and so forth. And then I'm going to go up the side. I'm going to go 2, 4, 6, 8, 10, 12, 14, 16. Okay, so first step is you guys always have to actually graph the points. So these are your x, those are your y's. So I'm first one says 3, 10. So I'm going to go find 3, go up to 10, put a little point. Next one is 5, 12, go to 5, go up to 12, put a point. Then it's going to be 4, 11, put a little point. 5, 14, put a little point. 3, 12, put a little point. 6, 15, put a little point, and then 4, 14. Okay, so we have a graph like this. So what we're going to try to do is we're going to try to make a line that best fits this data. So essentially we're going to try to make a line that actually goes through the data. So as you can see with my see-through ruler, I have some points to the left of this line, I have some points to the right of this line. I'm going to try to at least get 2 points that go actually on the line. I'm going to draw a line of best fit right here. Okay, you'll notice how there's about an even number on both sides, and it looks like it's where the data should be. Our next step is to find the 2 points that actually lie on the line. This one is 3, 10, 3, 10, and then this one looks like to be 6, 15. So what we're going to be doing with that is we have the 2 points now. We're going to be doing what we did a couple problems ago, and that is first find slope and then put it into point slope form and find it in y equals mx plus b form. So first step, label our points. This is going to be x1, y1, x2, y2. Okay, we're going to take y2, which is 15, minus y1, which is 10, over x2, which is 6, minus x1, which is 3. You can get 5 over 3. Okay, that's our slope. Then we're going to do y minus y1, which is 10, because that's what y1 is, what we chose y1 to be, equals m, which is what we just figured out, 5 over 3, x minus x1, which is 3. And we're here. So let's check out the y thing next to the y. Does it have 2 negatives? Nope. So our next step is to actually distribute this 5/3. So you put that in your calculator, 5 divided by 3 times -3. You can get y minus 10 equals 5/3 x, and you should get minus 5. Our final step is to get y by itself. So you have to get rid of this 10. You can get y equals 5 over 3x plus 5. So that's how you do that, is you're first trying to graph the points, try to find the best line that you think fits the data, take 2 of the points that either lie on the line or very close to the line, and do the whole process we did in the previous paper. Like these little things. How we did these, you do the same thing with what we just did. And then you're going to try these 2 down here. And once you get done with those, move on to the next problem. Okay, so chapter 3. It started out with substitution and elimination. I'm going to show you one of each, and I'm going to tell you how to tell when you're going to use either one. Substitution, you're always going to have some letter equals like this. In elimination, you're not going to have that. We're just going to have two equations that kind of look alike, and that the x's and y's are on one side, the numbers on the other side. And that's elimination. The other one will be substitution, is when you have a letter by itself. So once again, explaining what an equal sign means, it means equivalent to. That means that y is equivalent to 5x minus 5x minus 2. This means the same thing as like replacing a word in your paper with another word. Like if you said, I have a big giraffe. You could replace big with giant, it would still mean the same thing, right? I have a giant giraffe. I have a big giraffe, I have a giant giraffe. It means the same thing. Well, in here, if you have y, it means the same thing to say 5x minus 2. So if you see a y, you can replace anything you see a y with a 5x minus 2. Well, there's only one other place to see a y, which is down here. That means we're going to take this y out and replace it with 5x minus 2. So you can get 3x minus 2, and instead of that y, so I'm just repeating this equation right here, but instead of the y, I'm going to put the 5x minus 2. So there's going to be 5x minus 2 equals negative 3. Okay? So as you can see, once again, it's just the same equation. The only difference is instead of y, it's 5x minus 2. Next step is to distribute, because we always have to get that thing out of the way first. You get 3x, this is a negative 2, so it's going to be negative 10x plus 4 equals negative 3. Next step, combine like terms, the 3x and the 10x, so it's going to be 3 minus 10, which is negative 7x, plus 4 equals negative 3. And this is just a two-step equation from this point on. Is first you get rid of the number, get negative 7x equals negative 7, then you get rid of the number next to the x. So you get to divide by negative 7 on both sides. You get x equals 1. Now to solve for y, we have to go back up to this original problem up here. What that means is that I got to replace that x with what we just figured out x was. So we're going to figure out that y equals 5 times, what's x? Well, x is 1, minus 2. Okay, this would tell me that y equals 5 times 1 is 5, so you can get 5 minus 2, so y has to equal 3. So you have x equals 1, y equals 3. On the final, it's going to be multiple choice, so you'd see an answer like this, 1, 3. And that's the answer you'd choose. Because remember, this is just figuring out where these two lines meet. And they would meet at the point 1, 3. So elimination. This one's a little bit different. We first want to look at the numbers of the x's and the y's. We're trying to eliminate one of the variables, like it says in the name. So we're going to first look at the x's. So, can this top number multiply to give us the bottom number? Okay, yes, it actually can. But let's say we weren't so lucky, like down here, where you'd see 7 and 3. 7 can't multiply to 3 and 3 can't multiply to 7, so then you'd move on to the y's and do the same process, see if this can multiply to this or this can multiply to that. But in our case, we got lucky and the x's work. You do not always have to multiply the top equation. If these were flipped, you'd still be multiplying the smaller numbers. But you see a 3 here, you see 9 here. So we have to figure out how can we multiply 3 to get to 9. Well, 3 times 3 is 9. But there's a problem. If I just multiply this entire equation by 3, when I combine these together later, they're not going to cross out. The reason is one needs to be negative and one needs to be positive. So in order for this to be the opposite of this, I have to make this into a negative 9. So we have to multiply the whole thing by not just 3, but negative 3. Okay? It's always the smaller of the two numbers that we're multiplying the equation by. Next step is to actually multiply that negative 3 through. Okay? So you're going to get negative 9x minus 15y equals negative 63. I'm then going to take this original equation, the second equation, and just put it below it. I'm not going to change anything about it, I'm just going to put it below it. And now we know that these two are going to cancel out, so we're just going to add these two things together. So these two cancel out. The y's become negative 18y, and the numbers become negative 54. It's pretty easy to solve from here. All you got to do is divide by negative 18. You should get y equals 3. Once again, we're in the dilemma that we do not have the x, so we have to go back to one of the original equations, and instead of writing a y, we can write a 3. So I'm going to go back to this original equation and take 3x plus 5, but instead of writing the y, I'm going to write a 3, and then equals 21. Okay, so then we get 3x plus 15 equals 21. Get rid of the 15. Get 3x equals 6. And finally divide by 3. You get x equals 2. So your final answer would be 2, 3 on the test. So I want you guys to try the substitution and elimination problems on your own, and then move on to the next set of problems. Okay, next set of problems are inequalities. One where you have to just solve the inequality, the other one where you have to graph it. So we got to remember the different inequalities. You've got the less than, the greater than sign. Now, these, I'll explain what the number lines are here in a sec, but they'll have an open dot when you have number lines, and when you actually draw or graph it, it's going to be a dotted line. Then you've got the other ones that are like this. Got a closed dot. And then when it comes to graphing, it's going to be a solid line. It's going to come into play here in a sec. Okay, so inequalities act just like normal equations. But what I'm going to explain to you guys is that when we get to inequalities, we actually want to try to get all the x's over here. So I'm actually, instead of saying that, looking at the bigger of the two x's, I'm going to say the x house is always going to be on the left, the number house is always going to be on the right. And there's a reason for this. So first, let's look at the numbers. Okay, so what's in the x house that shouldn't be in the x house? Well, there's a -3, so we have to add 3 to both sides. Okay, we get 4x less than sign 9x plus 15. So remember, I'm just treating this like an equal sign. There's only one little difference about it, but we'll get to that here in a sec. Now, what's in the number house that shouldn't be? Well, it's 9, so I'm going to -9 on both sides. Minus 9x. So it's going to give me negative 5x is less than 15. Just like an equal sign, our last step would be to divide by -5. So we want to divide by -5 on both sides. And we get -3. Now, when you divide by negative, multiply or divide by negative, something happens to the inequality sign. It changes directions. So it's actually going to turn into a greater than sign. Our last step is to actually graph the results to show visually what this means. So what we do is I just make you guys just write -3. This does not have a line under it, so we know it's going to be an open dot. So I'm going to draw out an open dot. And because the x on the left hand side, because I made it so it would be on the left hand side by making this the x house, I can now graph by seeing which way does this little arrow point. As you can see, if it was like a little arrowhead, it'd be pointing to the right. So that's what I'm going to do. I'm going to make this and point it to the right. And then that's how you would solve this problem. Now when you look over here, what we're going to do is we are going to graph this. So we're going to, once again, pretend this is an equal sign. So we're going to graph this like this would be a normal y-intercept. Y equals mx plus b form. So you get two things. Remember, we got the -4, which is the y-intercept, and the 3/4, which is the slope. So we're going to do like the reverse process of what we did earlier with finding the line and figuring out the equation. So first we're going to start at the y-intercept. That's our starting point. We're going to find where -4 is on the y-axis, which is down here. Now, we've got a slope, it's 3/4. This means it's our rise over a run. It's a positive rise over a run. What I always tell you guys is that if it's positive, you're going to go up and to the right. If it's negative, you're going to go down and to the right. The reason why I tell you that is that there is other ways to do it, but that's the easiest way to remember. So this first I'm going to go up through. I'm going to count 1, 2, 3, which brings me to here. Then I'm going to go over 1, 2, 3, 4, and I'm going to put a dot. Okay. Now, before I actually draw my line, we look at this. Does it go with the dotted or solid line? Well, it's got that line under it, so we're going to draw a solid line. Now, what's special about inequalities is that you have to shade one of the halves of the line. To the top or the bottom half. Now, I always tell you guys to use the test point, and the test point is always right there at the origin, 0, 0. And technically what's happening is you're plugging in the 0 for the y and the 0 for the x. Let me show you what that means. So instead of y you write 0, instead of x you write 0. That's what I mean by that. You would solve that and see what it reduces down to. But the easiest way to even do this is because since this is going to cancel out, is to just write this. You write 0, you write the inequality sign, and you just write the number behind the x. Well, the number behind the x is a -4, so I'm just going to write -4. Okay? So when we look at this, it says 0 is less than or equal to -4. This can either be a true statement or a false statement. If it's a true statement, we shade on the half that contains this little point right here. So if the line was going up and down like this, the point would be on the left. If the line was going up like this, the point would be below it, so on and so forth. Doesn't matter where your line is. There's two halves, one that contains the point, which is this one right here, this whole half, and one that does not contain the point, which is this whole half. So if it's true, we're going to shade this side. If it's false, we're going to shade this side. So, is 0 less than or equal to -4? Well, 0 is bigger than -4, so this is actually a false statement. So since it's a false statement, we're going to shade on the half that does not contain this test point, which is this half right here. So we're going to shade this point. And that's all we're going to do. So, what I want you guys to do is you're going to solve the inequalities right here. You're going to graph them on the number line and everything. You're going to do both of these. And then you're going to go into this, and you're going to have 2. It means the same thing, just draw both of them on the same graph. And it's where both the shaded areas meet. That's what your solution set is. So like, if I had one of these little things, I had a line there, and then I had a line right there. Okay, so let's say I shaded on the left hand side of that, and I shaded on the cell's left hand side, and then I shaded below this diagonal. This part that they meet is the answer set. Now do those problems, then go on to the next part. Our final chapter, chapter 4. So first we're going to explain how to find an exponential function from a table, and then we're going to show how to graph it. So this first one, we got to look at this. A growth means that we look at the y's and the numbers get bigger as the x's get bigger. Or there's a decay where the numbers get smaller as the x's get bigger. In this case, the numbers are getting smaller, so this is called a decay. We're looking for a couple of different things. One, if it's a decay, it's dividing by something. So in this case, we're going to look at it. We're going to figure out what it's dividing by. So in your calculator, what I would do is I would take this and try to find the see if you can figure out what it's dividing by. Or you can look at the more simple problems where you get down here where it's like 32 to 8. What divided by 32 is 8. And you'll figure out that this first one is just divided by 4. So, it's just dividing by 4. And this is what's going to be our multiple. Now, in math, or not in math, in exponential functions, we can't actually have a division. So what we actually have to do instead is say that we're multiplying by a fraction. So multiplying by 1/4, remember, is the same thing as dividing by 4. So whatever you're dividing by 4, put it under 1, and then you'll get that fraction that we're going to be multiplying by. The second thing we want to look for is where does x equal 0 at? Well, it equals 0 right here. And our y value is 512. So this is what we do. We put y equals, our a is going to be what the y value is at 0, which is 512. Parentheses our multiple, which is 1/4. And x, because that's where the x goes. Just like in our linear equations, we have a y and an x. They're just in different spots than normal. Now, how to graph this. I always told you guys to do the simple version, so I always make a t-chart. We're always going to use 0, 1, and 2 because usually those are the easiest ones. I'm not going to give you one that you can't use 0, 1, and 2 on, so you should always be able to do that. Now, we are going to start plugging these in. So the first one is we're going to replace the x with what our x equals. So we're going to take 3. And notice how instead of an x, I'm going to put a 0 because our x is 0. The next one's going to be 3 4 to the first. Next one's going to be 3 times 4 to the second. Now, if you have a graphing calculator, this is pretty easy to enter in. Because all this is saying is you're taking 3 times 4 to the 0 power. This next one is 3 times 4 to the first, 3 times 4 to the second. And PEMDAS tells us always to do the exponent first. But if you have a graphing calculator, you would just put it in like this. You take 3 times 4, then you put a little caret key. It's one of those little things, and you'd put 0. Now, if you have a regular scientific calculator, this is going to be a little bit harder. So first, what you got to do is you got to take 4, then you're going to press, it's going to look like this, a Y to the little X button. There's going to be that little button down there. You can press Y to the X, and then you're going to press 0. Then you're going to press Enter. It's going to give you a number, and then you have to go and multiply it by 3. But just trying to put it in your calculator. Otherwise, you can just look at it like this. First one is 4 to the 0 power. Well, we know anything to the 0 power is 1. And then take that and multiply by 3. You're going to get 3 is your answer. Next one, 4 to the first power. Only thing to the first power is itself, times 3. It's going to give you 12. Next one is going to be 4 squared, which is 16, times 3, which is going to be 48. So I'm actually going to graph these. So I'm going to go up by 6. Okay, went up by 6. So the first one is 0, 3. So 0 is on the line, and 3 is going to be about halfway up. So I can put a point right there. The next one is 1, 12. So I'm going to do 1, 12 is right here. Next one is 2, 48. So 2, and we're going to go up to 48. Then I'm going to connect my dots. Make it look like a little part of a parabola. And remember, we always have to put the tail end, and the tail end is always getting extremely close to the line without actually touching it. So, this was a decay function, and this is a growth function. You can see one has a fraction, the other one doesn't have a fraction. That's usually how you can tell the difference. So right here you're going to be doing one decay function graph, one growth function graph, and then you're going to be done. Now this last part, I already did a video on this. It's called the exponent rules. Look that up if you need it. Otherwise, you guys should have the answer key to this whole thing. Check your answers and ask questions in class. Thank you.